Another 30 seconds. Everybody should type his ID in the chat panel. Just do it once, please. Cause confusion if you do it more than once. Just once. Everybody should type his ID in the chat panel, please. Okay. Extension 30 seconds. Everybody should type his ID in the chat panel. Type your ID in the chat panel to show that you are present, please. Last opportunity, 15 seconds. 10 seconds. 5, 4, 3, 2, 1. Thank you. Okay. No need now to type any ID. Thank you. طيب. So, inshallah, today we'll start a new chapter, chapter 5. As we said, after we finish 5 and 6, we'll go back and do a review for all the chapters. 1 and 4, we have lecture. We have 5 and 6 lecture. We have 7 and 8, 1 or 2 lectures. So we have quite good number of reviews. So we started chapter 1 in this course. I told you at the beginning of this course is like a movie. It's connected movie. Every scene is connected to the previous and the after scene. Type. Chapter 1, we studied measurements, and we said there are 3 important units: mass, length, and time. And from these units, we can derive other units. We also learned some geometry, and we learned some differentiation, and we learned how to convert between units and dimension and analysis. In chapter 2, we studied motion in 1 dimension. In chapter 3, we studied vectors, which is purely mathematics. And in chapter 4, we studied motion in 2 and 3 dimensions. As an application in motion in 2 and 3 dimensions, we studied projectile motion. We studied uniform circular motion on a circular track. And we studied relative motion in 1 and 2 and 3 dimensions. This is what we've taken so far. So what's new? Now, chapters 5 and 6 concerned with the effect of the force. So before, we've seen what happened after. We cannot see the force, so we can see sometimes velocity, we can see acceleration and displacement. In chapters 5 and 6, we'll see directly the effect of the force. So chapters 5 and 6 concerned with Newton's laws and their application on different forces, including friction, including normal force, including gravitational force, weight, everything. Type. So first we need to define what is a force. A force is either a pulling or a pushing action on an object. Yani, if you want to define what is a force can either do things, either push or pull an object. Now, the direct consequence of having a force is what's called acceleration, which you have learned in chapter 2 and 4. What is acceleration? Acceleration is a direct effect of a force. Yani, if there is a force, immediately there is acceleration. If there is, to be precise, a net force, some value, not zero, net force, there should be acceleration. Okay, there should be acceleration. This means that the effect of having a force, the indication that there is a force is a quantity called acceleration. Now, in this chapter or in this course in general, we study Newtonian mechanics, which means Newton's laws applies, and it has some conditions. We don't study Newtonian mechanics does not apply for speeds close to the speed of light. So all the objects you study in this course, they have limited speed maximum, like a rocket or like a car. But we don't talk about like speeds or velocities close to the speed of light. Another thing is that it is not valid for objects that are really small on the scale of the atomic structure. Scale of atomic structure means of hydrogen atom dimension or less. So it means we don't study very tiny objects in Newtonian mechanics or in this course, what's called classical mechanics. Those laws do not apply on two things. Do not apply on very fast moving objects closer to the speed of light. And we don't also study objects that their sizes are on the atomic structure scale. طيب, good important thing. Now, since we study forces and Newtonian mechanics, we need to study what's called Newton's laws. The first Newton law is called Newton's first law. So what is Newton's first law? Now imagine with me there is an object stand still on a table. There is an object stand still on a table. If this object is stand still, I can immediately say it has no acceleration. So this object has no force acting on it, has no net force acting on it, because there might be forces affecting an object, but a net force, يعني if you have one object and somebody is pulling from the right and the other one is pulling from the left in equal manner, يعني 10 Newton, 10 Newton, what will happen? This net force on the object is still zero. يعني let me show you here. Here, I have this object, and somebody is applying a force here, 10 Newton, pulling, and another person is applying another force also 10 Newton. What will happen to the object? The object will be stationary. يعني F net, اللي هو net forces on the object, will equal to zero. Good. Will equal to zero. Excellent. Even in the case of a gravitational force, هذه gravitational force, which is mg, but also I have a force we will learn in this chapter is called the normal force, which is equal to the mg in this case, if it's horizontal force. Okay? So a net force, يعني to be more professional, F net x and net horizontal forces is equal to zero. Well, F net y also equal to zero. Why I can do this? Why I can do this? Because the force, is it a vector quantity or a scalar quantity? It's a vector quantity. If it's a vector quantity, I can break it into force on the x-axis, force on the y-axis, and even forces on the z-axis. So if F net on along the x-axis is zero, means the object is stationary. طيب. So we understand an object that is stationary, that a net forces on it should be zero, means cannot accelerate. Good. So net force is equal zero, means this object cannot accelerate. ما في acceleration. But what's new in Newton's first law and what's new in Newton's look of this is the following. He said if an object was moving with constant velocity, also net force equals zero. Huh? This is new. Now, Isaac Newton said there is an object sliding, maybe sliding to the right, with V that is constant. كيف يعني V is constant? V is constant means 10 meters per second. It doesn't change direction. Keep sliding with the same speed or velocity, 10 meters per second. And Newton said this object doesn't have acceleration. So the conclusion also is that this object has net force equal zero on it. Then Newton's, in his first law, make it equivalent or equal for two objects. One object is stationary. He said the net force on it should be zero. And as a result, it has no acceleration. And another object that has constant velocity, and net force is equal to zero, and also the acceleration is equal to zero. فالآن بدك تغير المفاهيم شوية. Object is moving, not necessarily accelerating. We know this. Object is moving, okay, it's fine. Net acceleration can be zero, or net acceleration, if the net forces are equal to zero. So this is what's new in Newton's first law. Now, after Newton made the description of his first law, he started talking about second law. So what is in Newton's second law? Newton's second law, I'm sure all of you took it even in maybe elementary school. The Newton's second law said a net forces, which is a vector quantity on an object, should equal what? Mass multiplied by acceleration of the object. هذا Newton's second law. F net on an object, which is a vector quantity, important to put this arrow, equals the mass of the object by the acceleration of the object. What we can learn from this? The first thing we can learn is the following. We can extract a unit of the force. Okay, right side equals left side. This is in kilogram, and this is acceleration in meter per second square. But I know from elementary school that the forces are given in Newton. So what does it mean? Means now I can give description of the force in Newton. 1 Newton equals moving an object of mass 1 kilogram in an acceleration 1 meter per second square. وهذا the definition of the force. Definition of 1 Newton, this unit of the force in Newton, 1 Newton, which is abbreviated as N, is moving an object with an acceleration 1 meter per second square when that object mass is 1 kilogram. طيب ممتاز. هذا أول first thing we learn. Another thing we learn, a left side equals a right side. A left side is a vector. A right side has to be a vector. But what makes this right side vector? The acceleration. So what happens to this mass? What is this mass? هذه الماس, you should know, it is an intrinsic property. خاصية ذاتية. The mass of the object is inherently intrinsic property of the object. يعني ما تتغير, like density. Remember in chapter 1, we used to say you can calculate density if you calculate the mass and you divide by the volume. And at that time I told you the density of water doesn't change. It's 1 gram per centimeter cube or 1,000 kilogram per meter cube. It doesn't change. If someone has a big container of water or a small container of water, he will record the same density. It's a proportional thing. The same thing with the mass. The mass does not change of an object, which means my mass may be 80 kilogram, maybe. If I go to the moon, my weight, it will be recorded, will be less. وزني will be less. But my mass will still be 80 kilogram. If I go to another planet, if I go to space, and I can swim in space, I can swim in space. For example, if I go very high altitude, if I swim in space, someone will say, what is your weight? Well, my weight is almost like a feather because I can swim in space. But what is my mass is still 80 kilogram. Then the mass is an intrinsic property that does not change on anything. It does not depend on anything. Your mass inside the bottom of the sea is equal to your mass in the airplane, is equal to your mass on the equator, equals to your mass on the North Pole, equals to your mass on the South Pole, equals to your mass on the moon or any other faraway planet, or even in space. Then here we need to make distinction between two principles, al-mass wal-weight. And notice what I will do. What is the unit of the mass? Kilogram. Yeah, masses are given in kilogram. Main unit. طبعا في baby unit اللي gram. But what is this? And notice that I put an arrow on the weight, because the weight is a vector quantity. Actually, the weight is a force. Not just a vector quantity. It is by itself a force, which is equal to minus mg. And weight as a vector always points down, and it's equal to minus mg. What does it mean? It means weight is a vector, a quantity. Weight is a vector, a quantity. طيب. Then here we make distinction. It's important, this distinction between mass and a weight. A mass does not change, intrinsic property. A weight is just a force, and it's equal to minus mg. Excellent. I see good contribution. Yes. So either you can say the force is in Newton, or you could say the force in kilogram meter per second square. It's equal. Somebody is asking, or two students now asking, said, why minus mg? We know the direction of the weight force. احنا نعرف الدايركشن. The direction of the weight force is pulling objects down with the gravity. شوف هنا. شايف هذا؟ هذا فيكتور. هذا acceleration due to gravity. تعرف كيف عرفنا؟ minus 9.8 meter per second square. تذكر كنا قلنا هذا فيكتور يا جهات. It is a vector quantity and it is pointing toward down. Okay. طيب نسي. عندنا هنا هادي يبغى يسأل سؤال. Go ahead هادي.
فعلا دكتور. Doctor, if we have an object that moves, that takes a displacement, and that displacement went to the origin, so the displacement will be zero.
Yes.
Does it make sense that we say this object has no force
ليه شو علاقة وش علاقة هذه بهذه؟
if the displacement zero? That means there is no velocity, right?
There is no average velocity عزيزي.
Oh, I see. I
Yeah,
see.
be careful. Be careful. Displacement is needed for the average velocity, but instantaneous velocity, no. Object can be anywhere, can have different velocity.
True, true, yeah.
And if it has different velocity, and after a fraction of a second, a different velocity has acceleration. He has acceleration means there is a force. Right?
Right, yeah.
يعني خليني أوضح لك معلش good question. هذه when he goes the object هذا الorigin goes in this direction هذا velocity. But now when I go back, this is another velocity, right?
Right.
Direct, even if I keep the same velocity 10 meters per second, but I have direction change. So I have acceleration. If I have acceleration, means there is a force that caused this displacement. Okay?
True, yeah. Thank you.
Excellent, good. Right. So Newton's second law, mainly this F net equals, شوف حكتبه بطريقة غريبة شوي. Fx I hat طبعا net plus Fy net هذا y j hat plus هذا vector. I have the right to write it like this. It's a vector, can possibly be Fz into 3 dimensions. Net k hat حكملها equals ma. شوف واو. ومش بس كده، هذه ال A I can open it up. It is M AX I hat. هو ال A is a vector. I can also open it, you know, analyze it into its components plus M A Y J hat plus M A Z K hat. Oh, very nice. I can even open the acceleration, which means I can write the F net X as independent equation. We'll come to this. So here we have Newton's first law. If no net force acts on a body, or the body cannot change, then the body cannot accelerate. This is Newton's first law. Okay. Now Newton's second law, اللي هو F equal ma. Let's take first this checkpoint. Which of the figure 6 arrangements shown, okay, show the vector addition of a force F1 and F2? Okay, يعني which one of these 6 structures the components are, or the vector addition is correct? The vector addition is correct. If I take this one, what is this? This is this vector, and this vector equals this vector. As if I'm saying F2 equals F1 plus this. Okay? Which meant to represent their net force. لا هو he doesn't need addition. He needs which one represents a net force. هل النت force لهذا components of it is this one and this one? No, wrong. هذا vector, which I will redraw it here, his component should be this way and this way. But what you have is not this. You have vector up and you have to the right. So this one is wrong. So this is not a vector component. Let's take now this vector, هذا الvector. Analyze it, what it should be, up and to the left. But that's not. This one, F2, is to the right. So it doesn't work. Now take this vector, هذا. What are his components? هذه وهذه. Wow, hi, correct. F2 and F1 are two true components of this third vector. So C is correct. Yeah, C is correct. Let's take D. هذا الvector. What are his components? This one and this one. Yes, F1 and F2. So it's correct. So D is also correct. How about E? This vector. What are his components? Yeah, correct. هذه and this one. Yeah, so it is also correct. How about F? F should have this component and this component, and both of them are reversed. If you notice here, both of them, so it's not. So C, D, and E are the correct components of the vectors. From tail of the arrow, yes. It must be minus F1, correct, correct, good contribution. طيب. So as a summary, we said what is mass? We said mass is an intrinsic property of the object, and it gives me indication about how much material inside the object. وش هي الماس? الماس is how much material I have inside the object. An object that is massive has a lot of material inside it. Object that is not massive, the mass is small, almost empty. We said if equals ma, and notice this figure. Here somebody is pulling this cylinder to the left. By default, his acceleration should be to the left, to the right, sorry. This person is pulling the object to the right, and the acceleration should be to the right. Why? Because the direction of this vector should equal to the direction of this vector. This is the meaning of vector quantity. From the left and the right, they should be equal. Equal in magnitude, equal in direction. If the direction of the force to the right, هذا net force طبعا. If the direction of the net force to the right, the direction of the acceleration should also be to the right. This is important. And then we said, in Newton's second law, it said the net force on a body is equal to the product of the body's mass and its acceleration. يعني F net should equal to ma, this one here. And I show you before, if you open this, تكتب هنا fx I hat plus fy j hat plus, and here you open it, ax I hat plus ay j hat plus az k hat, what you get? You get 3 equations now, not one. You get now 3 equations. As if you're saying in Newton's second law equation, F net equals ma as a vector, I can break it or analyze it into 3 forces, into 3 equations. F net on the x should equal max, while F net on the y should equal may, while F net on the z equals maz. Maybe net forces on the x, if the net forces on the x equal to 0, means the acceleration on the x equal to 0, but maybe it has acceleration on the y, I don't know. Yani this equation indicates if an object doesn't have horizontal acceleration, he might have vertical acceleration. He might have vertical, it depends. If F net x equals 0, means ax equals 0. If F net y is equal to 0, means ay equals 0. If F net z equal to 0, means az is equal to 0. Okay, let me see. Maybe I have someone who raised his hand. Anybody have a question? Faisal, go ahead, Faisal.
Should the acceleration always in the same direction of its force?
Net force.
Yes.
Net force, yes, correct.
Always.
Maybe I have object affected by 1 million force, صح?
Yes.
لكن due to these 1 million forces, there is a force or direction will succeed to take it in its direction. The acceleration will be in that direction.
Okay.
Okay. يعني نجيب مثال من الواقع. Let's bring an example you guys learned. هذه البول, I throw it in the air up. It's flying up, right? You learned in the acceleration. Where is the acceleration? We said down, right?
Down. Yes.
Okay. So where is the net force of the object? Gravity, which is where?
Down.
Down. Yes, correct.
Okay, thank you.
The object, when I throw it up or throw it down, it always have a net acceleration down, negative. It means always the gravitational force is down. Okay? Right, good. Right. Now, let's take this example. If the net forces on a body is 0, its acceleration is 0. Yeah, if net, I told you, a body could have independent forces, but if the net is 0, means the acceleration is 0. So if the net force on a body is 0, then its acceleration should be 0 because net force is equal 0. The force and the body are in equilibrium, so the net force 0, but there may still be forces, as we said. For example, take this block on the ground here, هذا الground. It has one force up 15, and it has two forces 10 and 5 down. هذه الforces against those two forces combined, النت force على y equals 0. إذن F net y equal to 0 means AY is equal to 0. صح. I have net, if net y is equal to 0 means AY is equal to 0. And here in X, I have this force to the left, this force to the right. So if net X is equal to 0 means AX also should equal to 0. Which means 0 equals to 0 in X and Y. هذه اللي قلنا F net وهذه MA. Both sides are equal to 0. All the components 0, so everything is 0. Okay, excellent. I see good contribution. طيب. I need participation always يا شباب. Okay, always participate. Very nice topic and easy to understand, but you need to focus. Well, if I have net forces here, I don't have forces on the Z. I assume it is 0. I don't have any forces on the Z. I don't have motion on the Z axis. So I assume it's also 0. Okay? F net Z, as I said, he doesn't show me any forces of the F net Z. So means I will assume also it is 0. طيب. Mubarak Wahib, if you ask your question, unraise your hand. If it's an old hand, unraise. Mubarak Wahib. Go ahead.
Doctor, I don't understand how the net force is 0 and there may be still forces.
Yeah, هذا المثال اللي أمامك. هذا if net على y is equal to 0, but you have 15 force وعندك 10 Newton force, we have 5 Newton force. صح؟ يعني ال F net is 0, but I have 15 Newton. Not all the force is 0. I have 3 forces على ال y. I have 15 Newton, I have 10 Newton, I have 5. But the net action is equal to 0.
Okay.
Okay, good. Let me see another Dwayan Abdulaziz.
So, hello, Doctor.
Hello.
What if we have the an angle one, like 15 Newton?
هذا will come. Don't worry.
Okay, thank you.
Don't worry. Okay. So regarding the angle, we'll come to this. Don't worry about it. Right. Now let's take this example. The figure here shows two horizontal forces. طبعا, if someone asks you what are the forces you see here, and I see other two forces, later on we will learn. I have gravity here and I have normal force, but he doesn't want to discuss them. He said you have two horizontal forces, 3 Newton and 5 Newton. So we only study F net X. Okay. The figure here shows two horizontal forces acting on a block on a frictionless floor. Well, friction usually has a horizontal force, but when he said frictionless, in English means no احتكاك, no friction. So ignore friction. If a third horizontal force, if I add a third horizontal force, F3, that is acting on the block, what are the magnitude and direction of F3? I said, now you have these two horizontal forces, but I'll tell you a hint. I will add a third force, we call it F3, also horizontally. So he said, if a third horizontal force, F3, also added, what are the magnitude and direction of F3 if the block is to be stationary? Wallahi, if I add a third horizontal force, well, object will be stationary, it's not gonna move, it's not gonna slide, means if this is 5 and this is 3, I need to add the force here as 2 Newton, so that F from the right, the force from the right should equal force from the left. So he is stationary, which means his net acceleration is equal to 0. You guys agree with me? Everybody agree? Yes, 2 to the left. No, 2 to the left. To the left. Why? Because means I'm making it equal. 5 Newton equals to 5 Newton. Should be to the left. You agree with me? Now, هذا فرع A. فرع B said, how about if it is to make the object moving to the left with constant speed, 5 meters per second, huh? So that this object will be sliding with constant speed or velocity. Yalla, make your contribution. Where do you think that should be the direction and magnitude of this horizontal force? So that it's moving with 5. يا ويلي يا ويلي يا ويلي يا ويلي، دمار. الإجابات محبطة محبطة. It's Newton's first law. What do we say about Newton's first law? If an object moving with a constant speed or constant velocity, it means F net equals 0, means the acceleration is 0, means the net force is equal to 0. وكيف تعمل النت forces equal to 0? If this is 5, I need to add 2 Newton here so that this will also equal to 5. Very simple. So it should be the same answer. 2 Newton to the left, and here 2 Newton to the left. شوف تخيل, this example, he's equating a stationary mass with a mass moving with constant velocity. In both situations, a net force has to be 0. يا شباب بعيدها. If an object is stationary or moving with constant velocity, means they are, in physics, these two objects are the same, which means the net force is equal to 0, acceleration is equal to 0. فلما تقول 7 و10, it's not correct. It should be 2 Newton to the left, so that net forces on the right should equal in net forces on the left. I hope it's correct. I hope everybody agrees with me. If you disagree or anything, please raise your hand and ask me. Dwayan, do you have a question? Or old hand, maybe old hand. طيب, good. عندي ناصر الحماد. Go ahead, Nasser. Go ahead, Nasser. طيب, Abdullah Hassan. Okay, Nasser. Okay, go ahead.
أنا ولا ناصر؟
It's okay. Anyone. You start. No problem.
دكتور مو المفروض تروح to the right 2 نيوتن؟
ليه؟ If it's to the right بصير 7 against 3 بصير net force معناه net acceleration.
No, I'm not talking about the net force. I'm talking about the force.
طيب, if you said the answer I should add 2 Newton to the right here.
No, not this square will go to the right here because the force in the right much bigger than the left.
لا طيب, ما احنا عارفين, احنا بنقول الآن بدنا نعمل تغيير بحيث الobject should be moving to the left with constant speed. احنا السؤال انه yes, right, this طبيعي بدون ما نتدخل الآن. I have net force to the right means I have net correct, كلامك صح. Net acceleration to the right. But he said, I want you to make change, to add a third force, horizontal force, so that to make the acceleration 0 in both cases, A and B.
Okay, thank you.
Okay. Fine, good. عندي ناصر. Go ahead, ناصر. ناصر. طيب, حسين الغامدي. حسين, go ahead.
اي نعم دكتور وافق.
Yes.
انا قلت 7 الجواب, بس هو من القانون constant speed معناته 0 acceleration, فالجواب المنطقي هو 2 نيوتن to the left, نفس A. لكن لما افكر فيها, لما يكون 2 نيوتن to the left معناته it's not moving. فكيف؟
لا شوف الاوبجكت اللي moving with constant velocity النت فورس عليه 0. احنا ما نعرف. تعرف ليه؟
لا.
ممكن واحد دف اوبجكت وتركه ينزلق. حكيها بالعربي صح؟
حلو.
الان اذا ما حدا تدخل, هل هذا الاوبجكت اذا ما في احتكاك يبقى ينزلق صح؟ اذا هل في نت فورس على الاوبجكت هوريزونتال؟ نو.
لا.
but he's moving.
اوكي, got
احنا الايفيدنس on force is acceleration. If the net force is equal to 0 means the acceleration 0, but the object might be sliding, might be moving with constant velocity. No problem. Okay, good. طيب.
الحين فهمت, شكرا.
ممتاز. حسين الغامدي. حسين, maybe Hussein talked. Anybody has a question? If you ask the question, I'll raise your hand. If you don't have a question, okay, good. معناه طيب, good. Okay, let me see the chat panel. have time. Isn't FG act? Yes, I said FG is there وفي normal force, لكن أنا ما أبغى أتحدث هنا. هو يتكلم على horizontal. Those two forces are equal and opposite. يعني ال F net Y هنا اللي جاوب على الشات is equal, should equal to 0. Yeah, ما في, no problem. ما لها علاقة. It's okay. It's okay. No problem. طيب. هذه الحاجات foundational, but we need to understand it يا شباب. Okay. Let's take this extended example. طيب. Just give me one second. Which one of two forces act on a buck that moves over a frictionless ice? Frictionless ice means there is no friction. The buck mass is 0.2, so he gave you the mass of the buck. This is 0.2. The forces F1, F2 are directed along the x-axis and have 4 Newton or 2 Newton. So بالsituation الأول F1 is كم؟ 4 Newton. إذن هذه كم؟ 4 Newton to the right. What do you think will happen when I have 4 Newton to the right? Do I have acceleration? Yeah, I have acceleration. If you know the mass and you know the net force is equal to 4 to the right, can you calculate the acceleration بالsituation A? Yeah, I can calculate the acceleration. F net equal ma, so 4 Newton على 0.2 mass is 20 meter per second square. Means this object will have also acceleration to the right. Will have also acceleration to the right. وهذا الاكسلريشن is calculated. Okay, good. Now, let us calculate part B. Part B, I have two competing forces. I have F1, which is 4 Newton, and I have F2, which is 2 Newton, لليسار, left. What is the net force, horizontal force in this case? What is the net horizontal force? احنا ما نتكلم على الفيرتيكال. انا عارف الفيرتيكال، انا عندي gravity وعندي normal force. We don't talk about it now. Talk about just horizontal. So what is the net? The net, ال 4 to the right وال 2 to the left. The net will be 2 to the right. لانه ال 4 هذه اقوى من اللي to the left. So net will be 2. اذا F1 minus F2 is 2 Newton هذا كله. وهنا الماس 0.2. تحسب الاكسلريشن تقسم تطلع 10 متر. Means this object, let me see chat. Yeah, this object will be moving with an acceleration plus 10 to the right. Net action. Okay. طيب good. الآن يتكلم على الثيرد فورس اللي هي بارت سي. وش يتكلم على بارت سي؟ يقول there is a force F3 directed at an angle 30 degrees. وين هذه؟ شوفها؟ هذه الفورس. making an angle مع الهوريزونتال كم؟ هذه الانجل ثيتا. يعني let me just clear it here. هذه الفورس making an angle 30 degrees. لكن هنا بالسيتويشن C I don't have F1. I have only what? I have F2 and F3. Okay? الماجنتيود of F3 is small 1 نيوتن. أعطاك هذا الماجنتيود F3 هذه 1 نيوتن. لكن F2 كم قلنا؟ F2 2 نيوتن. هذه. Okay. In each, what is the acceleration? How to calculate؟ زي ما هذا سؤال زميلكم قال لما يكون في زاوية. اوكي. احنا وش نعرف لما يكون فيكتور وفي زاوية؟ we analyze الفيكتور. وكيف analyze it؟ هذه ال 1 نيوتن الانجل 30. هذا كوساين ولا ساين؟ هذا كوساين لأنه المجاور. إذا هذا ال F3x is كم؟ 1 كوساين 30. طلعنا الفورس الهوريزونتال. طبعا هنا الفيرتيكال وش يكون هذا؟ 1 ساين 30. هذه ما نشتغل هنا على الواي، ما نبغى نشتغل على الواي، فقط على الاكس، ويطلب على الاكس اونلي. اوكي؟ اذا الان الاناليسيز اوف ذا فورسز ايش عندي؟ عندي F3x بوزيتيف لليمين وعندي F2 نيجاتيف which is 2 نيوتن. سبستيتيوت هذه F3x اللي هي F3 كوساين ثيتا اللي هي 1 كوساين 30 ماينس ال F2 اللي هي ماينس 2 نيوتن to the left. وهذه تطلعني what؟ AX. Yeah, AX only. I need AX only. Divide by the mass تطلع minus 5.7. What does it mean minus 5.7? Means this object في third situation is moving to the left with an acceleration minus 5.7 meters per second square. هذا معناه right؟ or هنستغرب شويه هذا الاوبجكت moving to the right with a decreasing acceleration which yields minus 5.7 meter per second square. يتباطأ لليمين. يعني النيجاتيف ساين indicate يا اما يزيد باليسار او يقل باليمين زي الجرافيتي. الجرافيتي minus 9.8. Okay, so it means this object is moving to the right with decreasing velocity or moving to the left with increasing velocity. Both situations, the acceleration minus 5.7 meter per second square. Let me see. Wahib. Okay, go ahead, ya Mubarak.
Doctor, in situation B, how did we know the direction of the angle or the direction of the force?
Situation B ما عندي direction. Both of them horizontal. عندي 4 و 2. Just اطرحهم من بعض. I don't have angles. Situation B.
Yeah, but it says the net force accelerate in the positive. Okay, got it, guys.
Okay, good. عبد العزيز الحلافي.
حلافي دكتور. Yes,
Yeah.
دكتور. From where we get the one before the cosine? Why
هو
we say one?
السؤال. He told me F3 is 1 Newton in the question.
Okay. هو.
الماgnitude of F3 is 1 Newton. طيب. Anyone who would like to ask a question on this question? طيب, good. So we managed to calculate the acceleration in 3 different situations. Here, let's take another question. Let's take, if we said to the left, is it moving will be FD cosine or sine? If there is an angle, the force will be FD cosine. Well, it depends on where is that direction of the force. When I complete the triangle, is the component adjacent? Means it's cosine. If the component I'm trying to calculate is opposite, means it's sine. It depends. Let's take this another example, okay? In an overhead view, let me take a pen. هذا overhead view means you look from top, so you see things like كأنك في drone. تعرف الدرون؟ الدرون يعني bird eye or drone. أنت you see things from overview من فوق. In an overhead view, a 2 kilogram هذا cookie can علبة cookies 10 a cookie 10 is accelerated at 3 meters per second in a direction over a frictionless horizon. شوف الدايركشن هذا الاكسلريشن direction 50 degrees مع البوزيتيف x not on the x or the y. في acceleration sliding. طبعا this is x وهذا y وفي this cookie 10 علبة الكوكيز accelerating with an angle 50 degrees. Okay, في هذا معناه I can calculate acceleration. أعطاك magnitude of the acceleration which is 3 وأعطاك angle which is 50 degrees relative للpositive x. أعطاك إياها هذه بالرسم. The acceleration is caused by هذا acceleration طلع من 3 forces competing. 3 forces. So I have net force. The acceleration is caused by 3 horizontal forces, only 2 of which are shown. أنا في 3 forces. أنا أقول لك إنه في 3 forces, but I will show you only 2. أنت الثالثة يجب إنك تعرفها. Okay. If one of magnitude 10 نيوتن, هذه كم؟ هذه 10 نيوتن وهذه بزاوية. كم الزاوية؟ 30 degrees. لاحظ هنا. And if 20 نيوتن, هذه كم؟ 20. هذه 20 نيوتن up, يعني 20 جهات. 20 جهات. What is the third F3 force? طلع لي ال F3. وش أعمل أنا؟ أنا أقول كأني ال F net equals MA, right? لا ما في FG, ما نتكلم على الواي. هنا نتكلم هنا نتكلم XY على الأرض, ما نتكلم على gravitation. Okay? So here, as if I'm saying F1 plus F2, F3 equals MA. كأني أقول F net equals MA. هذا correct. How many forces competing? 3. أنا أعرف 2 of them. أعرف هذه وأعرف هذه وأعرف الماس وبعرف الأكسلريشن. من هذه الإيكويجن الآن هذه الإيكويجن ممكن تنقسم ل 2 equations. واحدة X وواحدة Y. Same equation. Right? ال X means MAX minus F1X minus F2X. وين ال F1X؟ هذه where ال X component ل F1 هذا النيجاتيف اللي هو كوساين. فشو يكون MA كوساين ال 50. طبعا هذه نيجاتيف، هذه الاف 1 كم؟ نيجاتيف. لاحظ الاف 1 از نيجاتيف. واي؟ لانه عندي فيكتور بروبلم. So it is to the left. So الكومبوننت الاكس نيجاتيف والواي also what؟ نيجاتيف. للاف 1 اتكلم. So MAX means MA cosine ال 50. يا analysis هذه. وش هذه الاكسلريشن اناليسيس؟ AX and AY. I need ال AX. الاكس وش تكون؟ كوساين ولا ساين؟ تكون كوساين. So MA كوساين ال 50 minus F1 كوساين. طبعا هنا انا اقول حط ماينس وكوساين ال 30. اتس اوكي. يعني لو هنا بدال هذه شو تعملت؟ F1 كوساين ال 30 يكفي خلاص. صح. يطلع معك نفس الاجابه. كوساين باي ذا واي كوساين ال minus 150 is equal to كوساين ال 30. اتس اوكي. هذا البوك نوتيشن. انا ايش افضل؟ افضل انك يو انالايز تقول في فورس هنا فورس لليسار means it's negative. خلاص هذه هي النيجاتيف. الان الاف 2 وير از الاف 2؟ هذه الاف 2. هل الاف 2 لها اكس كومبوننت؟ ساعدوني. هل الاف 2 لها اكس كومبوننت؟ لا. all the f2 is along the y. it doesn't have fx. معنى هذا التيرم مش يساوي زيرو. لما تحل الان تعوض وش يطلع معاك الاف 3x 12.5 نيوتن. اذا هذا عندها هذه الفورس اف 3 لها كومبوننت موجبه 12.5. خلينا نطلع الواي كومبوننت and then we can find a net force. How to find the y component؟ من equation الواي MAY. طبعا ساين ال 50 not cosine 50. ساين ال 50 هذه ساين ال 50 للاكسلريشن ماينس F1 وهذه لها نيجاتيف ال F1 لكن ال F2 بوزيتيف. لاحظ ال F2 بوزيتيف. هذه should be هذه ايش تطلع؟ هذه بوزيتيف. سبستيتيوت تطلع معك كم الاف واي؟ اف 3 واي ماينس 10. وير از الماينس 10 على الواي؟ هذه. اذا الدايركشن اوف ذا فورس should be this. والماجنتيود I can find it. هذا الماجنتيود means اللي هو سكوير الاكس وسكوير الواي اندر ذا سكوير روت طلع 16. لاحظ الانجل كم طلعت؟ يا سلام. واحنا وي بريدكتد انها تطلع كذا ماينس 40 degrees. Anyone has a question? No. Okay. Sign. NO. Okay. No. Okay. طيب. ممتاز. Anyone has a question? طيب يا شباب we have less than 30 seconds. طيب what I want you go over this slide, solve these examples and checkpoints, about 5 examples today. Solve them by hand. Make sure you understand. If you have any question, you can ask me next time. We can stop here inshallah. Assalamu alaikum.